Okay, this is what I meant. A vector contains information on the magnitude and the direction. Okay, and the reason why you can split them up into components is shown here in this little sketch. Here you have this red vector. Then you can look at the projections onto the x-axis, onto the y-axis, and onto the z-axis. These are the names. Okay, so now scalars are something different. They are just numbers, like the temperature distribution or pressure itself is also, they don't have any direction. This is what we call a scalar. And I'll show you one example of a scalar. It's a distribution of elevation above sea level. It's shown here. These black lines are actually contour lines. We call them contours. They connect regions which have the same value. Here you can see, for example, this is a 1,500 meter line. Then you have a 1,000 meter line and a 500. Okay? And important little detail when you use contours is that you have to use the same contour interval. The interval is the difference in values between adjacent lines. In this example, the contour interval is 5. Okay? So now this is a scalar. It doesn't have an orientation, but what has a direction is so-called vector gradient. So it tells you actually in this example of the elevation, tells you about, gives you information on the steepness. In which direction do you have the steepest gradient? Okay, so you have a scalar field, which is elevation here. You can work out the vector gradient. This is how it's done. It has two components. In this example, this is how the elevation changes in the x direction. How does it change in the y direction? And then using Pythagoras, you can again work out what is the steepness, overall steepness. All right. And that's important to know, because pressure gradients are the central cause of currents and fluids. It's not the pressure, it's the gradient in pressure that is a force and that produces acceleration.